Here we'll work this window motor drive, this example here. Say analysis, we want to determine the velocity ratio. Here we're going to assume the output is gear 4 right here. The input will be the motor, which is gear 1. And we also want to find the efficiency of this gear train. We'll determine this just in terms of the gear tooth numbers. So it's a fixed axis gear train, fixed axis. That's all we've seen in the early work. So we need the ratio of the output over the input. The output is gear 4, the input is gear 1. And we'll write this ratio as a linear combination, as a linear product of all the gear contact ratios. So we have omega 1 drives omega 2, and omega 2 drives omega 3. Now, we can observe that 2 and 3 are compounds, so we know that that ratio will equal 1, but we'll just carry it at the moment. And then omega 3 drives omega 4. So we can see the linear nature of velocity in these gear trains, and we can see everything cancels, so we get the same equation as before. Next, we apply the fundamental law of gearing, so the ratio of 1 to 2 is the inverse ratio N2 over N1. Oop, get that wrong. N1 over N2, that inverse the ratio. The ratio here of 2 and 3, they're compounds, so that's 1. And the ratio here, these are also external gears, so I get a negative N3 over N4. So my gear ratio, omega O over omega I, is positive N1, N3 over N2, N4. So if I had the gear teeth numbers, I would plug them in and solve. You can see gear 1 is a worm, so it's possible to be 1 tooth or 2 teeth. This guy looks like he's got 20 or 30. This one might have as many as 60. But we'd count those or get those. Next to X asks for the efficiency. So we want to get the efficiency of the gear train. And that is given as the product of the individual efficiencies for I equal 1 to the number of gear trains we have, we'll call N. In our case, we have 2, so it's going to be eta 1 times eta 2. So the first stage, it says the gear ratio efficiency is 45%. Second stage is 85%. So we can calculate this. So the efficiency of the gear train, 45 and 85, is 38.25%. So not terribly efficient. Okay.